All right, we're back. We're on page 6 of Notes 13. And what we're going to talk about now is a slightly unorthodox situation in which u-substitution can help you. So u-substitution, super useful. It pretty much always turns a problem into just reversing the power rule. Sometimes it's not super obvious what to make u, and sometimes it's not super obvious how a u-substitution is going to help you. The problems on this page are basically all of that type. So what I'm going to do is I'm just going to dive in, and I'll show you, in some cases, multiple ways of doing it. So the first thing I see is a problem that I don't know how to do. And I'm like, there's not really an obvious choice of u. I mean, I feel like typically I would make u equal 5 minus x. And I think that'll actually work. So let me do that. So I'm going to say, I'm going to do two different approaches, so two different colors. So let's say that u is equal to 5 minus x, right? So then I know that negative du is going to equal dx. That's all good. But I need to replace x, right? So this will become u to the 1/2. This will become negative du. But what is this? Like, you have to replace every x you see with some sort of u. So what I'm going to do is I'm going to say from here, x is equal to u minus 5, right? So what I basically did was, 5 minus u. 5 minus u. I did it wrong. Then I'll tell you what I basically did. 5 minus u. I added x to both sides, and I subtracted u from both sides. So x is 5 minus u. So now my integral is going to be x becomes 5 minus u. 5 minus x is u, so I get u to the 1/2. And then negative du. And now I can rewrite, I'm going to expand 5u to the 1/2 minus u to the 3/2. A lot of exponent work here. Get this. All right, so this will be a negative quantity. Plus 1 times the reciprocal is 10/3 u to the 3/2. And then plus 1 times the reciprocal, 2/5 u to the 5/2 plus c. Okay, but then what's u? U is 5 minus x. So this will become, I'm going to distribute the negative. So first of all, there's a million caveats to this. One of the caveats is that this factors. You can take out a u to the 3/2 from both of these. And if you take out u to the 3/2, this becomes u to the 2/2, which is just u to the first. So like the calculator version of the answer to this will be much more simplified, I guess, than what I'm about to get. But like usually I don't think it's worth it unless it's a multiple choice question, in which case you have to do that to match the answer. I pretty much am just going to leave this. I'm distributing a negative, so that becomes plus. I'm going to leave this the way it is, even though I do know that this factors. It actually factors in kind of a useful way, and you could like potentially find one of the zeros of it if you needed to, but it's not a derivative, so knowing the zero isn't like super helpful. All right, that's method 1. Method 2 is similar, but instead of letting u be the thing inside the radical, let u be the entire radical. So I'm going to say u is the square root of 5 minus x. So u equals the square root of 5 minus x. So now what happens? Do not try to find du at this point. Only find du after you've isolated x. So we're going to have to do all the same substitutions. Like, we still need to replace x. So I'm going to solve this thing for x. So I'm going to square both sides. And get u squared is 5 minus x. Could find dx here, but like we need to solve for x anyway. I'm going to say that x, so I'm adding x and I'm subtracting u squared. 5 minus u squared. And then from here, from this part, well, no, from this part, from whatever, I'm going to say dx is negative 2u du. All right. So let's make all of our substitutions. Remember, we're going back to the original. So we got to replace x. So we'll have x is 5 minus u squared. And then the radical thing is u. So that's just times u. And then dx has negative 2u du. So I'm going to pull the negative 2 out. Negative 2. And then you get times u du. So the nice thing, when you make u equal the entire radical, the nice thing about it is that you don't have to deal with rational exponents. I hate dealing with those if I can avoid it. So like I think that this is the better way to go. But again, it's very much a choice. Here, let's simplify this. So that's u. This is u squared, and we'll distribute that. So you get 5u squared minus u to the 4th du. Now it's all reversing the power rule. So we'll get negative 10/3 u cubed, and then plus 2/5 u to the 5th plus c. So can you see right now that this answer and this answer are actually equivalent? Like, can you see that? What's going to happen is when I replace u, I'm replacing it with 5 minus x to the 1/2. So this is going to become 3 halves. This is going to become 5 halves, 3 halves, 5 halves. Same exact answer. I think it's a little bit easier. So it's up to you what you want to do. And this is the kind of thing, like in the last video where I couldn't, or 2 videos ago when I couldn't remember arcsine was a thing, like I forgot it existed. Sometimes you'll forget this exists, and you'll just do it whichever way first strikes you, and you'll still get it. So it does make a difference. I feel like that was like a long example. I'm gonna do, all right, I'll do one more, and then I'm gonna cut it and do the next one in the next video. So here, I'm gonna make what I believe to be the best choice right away. I'm gonna make this whole radical. You don't need to, you can make u equal 3z plus 2. I'm gonna do radical 3z plus 2. Because I won't have to deal with rational exponents, and I don't really want to. So let's say u squared minus 2 divided by 3 is equal to z. So what I did was I squared both sides, which is where u squared comes from, and then I subtracted 2 and I divided by 3 to get z by itself. From here, I can get that dz is going to be 2/3 u du. Okay, so I have everything I need. I have to substitute for z, but I'll substitute that. For dz, but I'll substitute that. And then for this thing, but that's just u. All right, so I think we're good to go. There's like a lot of constant multiples, right? When I substitute for z, I'm going to pull this 1/3 out. So I'm going to have 1/3 and then u squared minus 2. When I substitute for dz, there's a 2/3, so times 2/3 u du. And then when I substitute for this, it's just u. And so like really nicely, there's a lot of like simplifying here. I get 2/9 the integral of u squared minus 2 du. And we're good to go, sort of. Okay, so 2/27 u cubed. I'm like distributing the two, so minus 4/9 u plus c. You can see right off the bat that this factors. Actually, I should have mentioned that here. The version that you do where you make u equal to a whole radical, way easier to factor. Like here you can see, definitely take out u cubed, and it's gonna work. Here you can see we can definitely take out a u to the 1st, and it'll work, but like I don't really want to do that because I don't think it really helps. Well, I mean, it does help. Whatever, I don't want to do it. What's nice though is if we do it, we get u squared here, and then when I square this, it just kills the radical, so I end up with just getting 3z plus 2. So you get like these really nice answers. I'm gonna actually, because I'm not doing more problems, I'm gonna try to get the calculator to, I guess, check our answers. How am I gonna do that? I mean, I can ask the calculator to find the antiderivative, but I know that it's gonna simplify it. Also, I'm going to rational exponents here, in case you missed that. Okay, so that's my answer. I think it's probably right. I'm gonna go to the calculator, and you can see where I did the arcsine problem, like when I was totally lost. When you get lost, let the calculator be your guide, you know? All right, let's see. So if I do the integral of, so I'm going back to the previous problem, integral of x times square root of 5 minus x with respect to x. So by the way, there's a template for that. So there's the definite integral template, where honestly, if you just don't fill in the bounds, it does an indefinite integral. But on the next line, there's the indefinite integral, and use that. It can do it. So this doesn't really look like either of our answers, like even remotely like them. Why is that? 2/5. Okay, so what I think we need to do is type in our answer and take the derivative. Derivative with respect to x of. Like, I got the same answer 2 different ways, so if it's wrong, that's really disconcerting. Not unprecedented, but disconcerting. 5 minus x. Is it like a bee that's banging its head into my window? Don't like that. Yeah, and then there's plus c, but like whatever. You don't need to type that in because the derivative is 0. What are we doing here? Factor? Is this equivalent? I don't even think that's equivalent. X radical 5. What is this? I mean, like, so it's like if you take out this, you're gonna be left with 5 minus, if I take that out, I'm left with like 5 minus x. I'm left with this, but I don't know why won't you simplify? It's gotta be a domain issue, is my guess. I don't know. But anyway, that's the original integrand, so that's definitely right. So we got it right. The calculator can be annoying to work with on these. Another option is to graph your answer and graph the calculator's antiderivative and just see if they match up. That's actually like a really good technique. I'll do that on the next one. So here, like I would type 2 over 27. One reason you might, well, I gotta use x. You might want to factor your answers. It's just easier to work with. That's like factoring 101. Like, why use a factored form? Because it's superior. Okay, so I'm graphing that. I'm also going to graph the integral and c. So like, they could potentially differ by a plus c. I'm not even going to speculate. I was going to say I don't think they will, but could. Plus 2 dx. There we go. You see how they completely overlap, so they're going to be the same thing. It's another really good visual way of checking. So I'm going to stop the video here, back to the notes, I guess. So a couple things you could have factored. I definitely have other videos of not me doing the notes, but me doing extra problems where I do go through and I factor these sorts of things because I do think it's important, but like maybe not so much in the context of just getting this concept down. So let's stop this here, come back in the next one and do the next part. So see you there.